Hello everyone, welcome back to today's class. In this class, I want to show something I didn't talk about in the last class. I discussed about it, but I did not talk about it. So I feel the need to just show it before I move to the next trig angles we are going to prove. Now, this is the triangle, right angle triangle that we are using for our calculation, which we've used to prove everything we have been doing in this class. So for the tangent, the calculation I did for the tangent, I used the sine over cos formula. But now let's show the real SOHCAHTOA that we mentioned. Remember when we said SOHCAH, sorry, SOHCAHTOA. The target is opposite over adjacent. So let's use it and also prove that we'll get the same answer. Now let's do tan 60, which is opposite over adjacent. So it's just going to be opposite is root 3, as we saw in the triangle, over adjacent, which is 1. So it's still giving us root 3. The next is tan 30 is degrees. This is tan 30. This is 30. Opposite over adjacent. So opposite is 1, adjacent is root 3. So we're going to get 1 over root 3, which we can also rationalize as 1 over root 3 times root 3 over root 3. And we are going to get root 3 over 3. These are the two answers for tan 30. So if you look at this, you can see that this is tan 30. We got the same answer. And when we rationalize, we got this. This is tan 60. When we use the sine formula, we still got the same answer. So for tan 90, degrees and tan 30 degrees, those are special angles that, as I said earlier, I will not be able to, I will not prove them in this class. It's beyond the scope of this class. So you can see that these are special angles, and we already know that tan 90 is infinity, while tan 30 is 0, still giving us the same answer we got in the previous class. So now let's move to the next angle we are going to prove. So the next angle we are going to prove is angle 45 degrees. The other triangle could not prove it because from the design we did in the other triangle, you can see that there was no space for it. So this is it, how we prove it. Now this is a square. Mind you, this is a square. I know that the shape looks like a rectangle because I didn't draw it to scale. It's a rough sketch. So let's say the size of this square is 1 unit each. And now what's the total angle of a square? All these are basic elementary, so it's 360 degrees. In the total internal angle of a square is 360. But since this is a square, everywhere here will be 90 degrees. Here is 90, here is 90, here is 90, because when this is 4 angles, if you divide this by 4, you get 90 each. But this diagonal is dissecting this angle equally, so here will be 45 degrees, here will be 45 degrees. So 45 plus 45 is still giving us 90. So here too is 45 degrees. So the next thing we are going to find is what will be the length of this diagonal here. We use our Pythagoras theorem. Let's call here C, let's call here B, and let's call here A. So C square will be equal to B square plus A squared. So C square is what we are looking for to remain in C square. A square is 1 square, B square is 1 square. So C square is now equal to 1 plus 1, because 1 square is still 1, so which is equal to 2. So C square is equal to 2. To find C, we'll find the square root of both sides. So C is now root 2. So we have root 2 here. So this is trig we are doing, but because we are dealing with surds, so we're using surds to express them. When you punch your calculator, you see that everything we are getting is the same as all the answers we are getting here. So now, after this, let me sketch out the new triangle. I'm going to sketch out this out. So I'll have something like this, this, I know is rough, pardon me for that, and it's a right angled triangle. Yeah, this time around the angles are different from the first one. This is 45 degrees and this is 45 degrees, unlike the one that is 60 and 30. Here is 1, here is 1, and here is root 2. So this is what we are using to solve for 45 degrees. Now remember our so ka twa. So sine 45 degrees. This is already we are dealing with here because we proved the other ones in the previous class. Oh, sorry. Sine 45 degrees will be 45 is opposite over hypotenuse, which is 1 over root 2. This is the answer. In case if you see this answer, no, it's correct. But mostly in solve, we don't like leaving the square root under. So I'll work on this further. It will be 1 over root 2. We remember our calculation how to remove the root from the denominator. So this will be root 2 all over. When 2 surd multiplied by itself, it gets 2. So this is sine 45. The next one is cos 45 degree. Now so means opposite over hypotenuse. Like I forgot to say. Now cos is ka, adjacent over hypotenuse. So the adjacent is 1 over hypotenuse. It's still the same, 1 over root 2, which is still giving us the same root 2 over 2. Then tan 45 degrees is now opposite over adjacent, which is 1 over 1, which is 1. If you still want to solve it using the other formula I gave you, which is sine over cos, you can still use tan 45 degree will be sine 45 degrees all over cos 45 degrees, which should give you 1 over root 2. Let's assume I'm using this particular one, divided by 1 over root 2. And when you're dividing a fraction, you just call it 1 over root 2 times, then you will inverse it, root 2 over 1. So you see that everything cancels out and still give you 1. So any formula you want to use for the tan, whether you use this one or you use that one, you still get the same answer. So this is for 45 degrees. Let me summarize what we've gotten so far. So this is a summary of the special angles we've done. This is a summary of all the special angle that we've done, and we've got the answer using Surds. Now, mind you, do you observe something? These angles are just from 0 to 90. Though this is outside the scope of this class, I would like to touch it. If you are dealing with angles that are above, let me say from 90 to 360, how do we solve it? There is a formula I will explain to you. Let me say this is a circle. And let's say this is a quadrant of the circle. Let's say this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. Now everything we did here is in the first quadrant, because this is 90 degree, another 90 degree, another 90 degree, another 90 degree. So this is from 0 to 90. Let me say 0 to 90. Second quadrant is from 90 to 180. 90 plus 90 is 90. third quadrant is from 180 to 270, and fourth quadrant is from 270 to 360. So what do I mean? Any angle that is from 0 to 90, this is the answer for the special angles. Anyone that is from 90 to 180, I will show you the formula on how to, the shortcut on how to get it. Any angle that is from 180 to 370, which is the third quadrant, and the fourth quadrant. So I'll just show you the formula on how to solve it. Now, this is how we can solve for angles above 90 to 360.